Hey, welcome back. Common Core Algebra 2. Today's lesson is 10.5 Complex Fractions. Now, I'm not going to lie, this is not a very easy lesson, but I'm going to try and take it slow with you and really, show you the easiest way to do this. And as you do them more often, you'll become more proficient at it, and then you'll be able to do your own shortcuts. But I'm going to kind of show you the long way to do it, and then after that, you can kind of come up with your own way of simplifying these a little bit easier. And if you'd like me to help you with that during class, I can. All right, so we're going to start with a really simple complex fraction with just numbers and not variables, although this doesn't look very simple. So A says, what is the least common denominator amongst the three minor fractions? The minor fractions, I mean the 1/9, the 1/18th, and the 1/3. So if you think about it, what numbers is the least common denominator? Which number is the least common denominator between 9, 18, and 3? And just to remind ourselves, it's the multiple that all three of them, the least multiple that all three of them go into evenly. And the answer in this case is 18, since 3 and 9 both go into 18. B says multiply the numerator and the denominator of the major fraction by your answer in part A and then simplify your result. So what basically I'm saying is if you multiply the top by 18 and the bottom by 18, we can simply just multiply straight across, and we can kind of use the distributive property here a little bit. So basically, I'm going to work up here only because it's just easier. So you're going to get 18 times 1, which is 18, over 9, plus 18 times 1 is 18 over 18. So that's the numerator of my big fraction. And then I'm simply going to multiply 18 times 1, which is 18 over 3. And then in my next step, I can do some simplifying of each of the fractions. So here is my big fraction bar. On the top, 18, so I'm right here. 18 divided by 9 is 2. Plus 18 divided by 18 is 1. And then 18 divided by 3 in my denominator is 6. All right, so my final answer here is 3 over 6, which of course reduces one more time to 1/2. So C says, why is it acceptable to perform the operation in part B? What number are you effectively multiplying by? Well, hopefully you're recognizing that 18 divided by 18 is the same thing as multiplying through by 1. All right, so here we're multiplying by 1. And remember, there's no equal sign here. We're simply just simplifying a fraction into a simpler form of that fraction. All right, and the only thing that we can multiply through by is 1. It isn't like when there's an equal sign there and we can multiply through by the same common denominator like we've talked about before. All right, here we're just simplifying, so you can only multiply through by 1 and not change the value of the fraction. All right, so finish writing that down and meet me on at exercise 2. So by multiplying the major fraction by the number 1, and by using the least common denominator, we will always eliminate the minor fractions by turning them into integer expressions. So again, A is going to be a little bit easier because there's no variables involved. So the first thing you should be thinking about is what is the LCD, the least common denominator, of 2, 10, and 5. And hopefully you're realizing that it's 10. All right, so what we're going to do is we're going to multiply the top, the numerator, by 10, and we're going to multiply the denominator by 10. Again, it's really only multiplying by 1. So again, we're going to use our distributive property here and just multiply through by the numerator. So we get 10 times 1 is 10 over 2, minus 10 times 1 is 10 over 10. Here is our big fraction bar. And 10 times 2 is 20 over 5. So we're going to do some simplifying again. Here's our big fraction bar. And our numerator, 10 divided by 2 is 5, minus 1. 10 divided by 10 is 1. And 20 divided by 5 is 4. So we're going to just reduce that. I'm just going to make some room over here. And 5 minus 1 is 4 over 4. So this entire fraction reduces to 1. Boy, I didn't see that looking at that problem. So now things start getting a little bit more difficult because we're going to start introducing some variables to this. But we're going to do the same process. We're going to look again, and if it helps you, what are the denominators? We have 3, we have x, and that's all we have. So in this case, we can just simply multiply them together, and we're going to multiply the numerator and the denominator by that 3x. So I'm going to use my distributive property. Remember, when we multiply, we don't multiply the denominator, just the numbers in the numerator. So 3x times 2 is 6x, all right, plus 3x times 2 is 6x, and this is going to be divided by 3 divided by x. Here's my big fraction bar. So the minor fractions, all right, we're okay so far. So now I'm going to do 3x times 5, which is 15x over 3, plus another 15x over x. And now we're going to simplify. And just pull it down a little bit. So when we simplify these, in this case, 3 cancels into 6, and I have a 2 left. Here the x's cancel. So here's my big fraction bar. So in the top, in the numerator, I simply have 2 plus 6. Oh, sorry, 2x plus 6. I almost missed that x right here. So I have 2x plus 6 over here. This cancels 1 and 5, so I'm left with a 5x. And here the x's cancel, I'm left with 15. But if you take a look at the 5 and the 15 and the 2 and the 6, hopefully you can realize that we can simplify this yet a little bit more. Because here's my fraction bar. In the numerator, I can pull out a 2, and I'm left with x plus 3. That's like if I just factor out a 2 out of each of these. And in the denominator, I factor out a 5. Same thing, I factor out a 5 out of each of these, and I'm left with x plus 3. And because they're both in parentheses, and they're exactly the same, now I can cancel these. So my final answer here is going to be 2 over 5. Now your answers aren't always going to end up as real numbers, and the x's aren't always going to be eliminated. So let's take a look what C brings us. Again, at this point, if you need to pause, write things down, make sense of things, do that before we move on to C. All right, so what do we have here? We have 8, we have 4x, we have 2x, and we have 4. Those are all the different denominators that we have. So if I look at the numbers, 8 is going to be my least common denominator because 2 and 4 both go into 8. And I have 1x. So my common denominator is going to be 8x. So what that means is I'm going to multiply this side by 8x and this side by 8x. I'm sorry, in this denominator. So again, using the distributive property, here's my big fraction bar, and I want to always make sure that I'm keeping that separate for you guys. So now I'm looking only in this numerator. So 8x times 3 is 24x over 8 plus, and then 8x plus 1 is plus 8 over 4x. That's my numerator. So now we're going to take a look at the denominator. 8x times 7 is 56x over 2x plus 8x times 3 is 24x over 4. And again, we're just going to be doing some simplifying now. Maybe I can even slide it over to here. So in my numerator, here's my big fraction bar. 24 divided by 8 is 3x. and 8 divided by 4x, oh, I'm sorry, this is an 8x here, missed that one, because I noticed I was going to get a fraction and I can't have a fraction. So I'm going to get plus 2, all right, over, and let's do some simplifying here. 56 divided by 2 is 28. So these cancel, the x's cancel. So here I have 28 plus and 24. Again, this is supposed to be a, this is going to be a 6x over here. So can I reduce this anymore? And the answer is no, I really can't. I could take out a 2 out of the bottom, but it isn't going to help me because I don't have a 2 to take out of my numerator to cancel. So you can just leave it like that. Okay, if you wanted to, you could use the commutative property in the denominator and make it 6x plus 28 if you wanted to. If it's a multiple choice, remember they can do some manipulating there to get a different answer. And especially in Algebra 2, they're going to be doing those kind of things on your multiple choice questions. All right, write down what you need to. And meet me at exercise 3. Okay, so in 3, it's kind of the same. It's just a continuation of what we just did in exercise 2. So let's look at A, and then I want you to do B and C on your own. Actually, you know what? We're going to just not even do C. Don't worry about that. Let me do A, and then you can do B, because I just think that there's just too many things to do here. All right. I think I might have even taken C out of it. I'm not sure. So let's take a look at our common denominators. So here I have 2, I have x squared, I have 2x, and I have another x squared. So 2 is going to be my least common denominator. And then I have x squared, because x goes into x squared and x squared goes into x squared. So what that means is I'm going to multiply both of these, numerator by 2x squared and my denominator by 2x squared. And when I do that, use your distributive property, I get 2x squared times 1 minus 2 times 2 is 4x squared. All right, this was over 2, this was over x squared. Our denominators don't change in our minor fractions. All right, and then we use a distributive property here and here. So here we get 6x squared over 2x minus 6x squared over x squared. And now we're simply going to simplify. No pun intended. All right. So cancel. So I'm left with, here's my big fraction bar. So I'm left with x squared, because the 2's cancel, minus, again here, the x squares cancel, so I'm left with 4, over, this goes to 3, and these x's cancel, but I have a 3x left, 3x minus, and here the x squares cancel, and I get 6. So we have a little bit more that we can simplify, because hopefully you've got red flags going off right here, because we know that's the difference of 2 perfect squares, which is going to be x minus 2, x plus 2, all over, and my denominator, I can easily factor out a 3 to an x minus 2, and we get to factor out again. So these are minuses, they both cancel. So my final answer is going to be x plus 2 divided by 3. Remember, you can leave these parentheses around it just to remind you that they are protected. So write that down, make sense of it, and why don't you try B on your own? Okay, here are the answers. Okay, so there are the solutions to B. So you might want to just take a minute and pause the video here and kind of see what I did and compare it to what you did. Okay, I'm going to have to take a short break. while the next class comes in, and then I will go on to exercise 4. So this is a good place for you to take a break, or maybe you want to even look at exercise 4 and see if you can make heads or tails out of it. Okay, I'll be back in a minute. Okay, so I'm back. Sorry for the interruption, although you didn't have much of a pause there. We are on exercise 4. And this is what our complex fractions will look like in Algebra 2. So the first ones that we've done really were just in preparation for this. So what we have to do is we're going to follow the same method that we just did, although this time we have binomial factors. So if we take a look here, and again, I like to do this because I like to remind myself that they are protected. And here's my big fraction bar. So my common factors, if you notice that in the denominator down in the bottom here, I have a trinomial. So I can rewrite that, all right? So let's see what I'm going to have. I'm going to have 4 over x plus 2 plus 2 over x minus 4, big fraction bar, 12x minus 24, and I'm going to factor this trinomial, and it should be a fairly easy one to factor. And they usually are all factorable. They all are factorable, not even usually, because if they want you to cancel things out, you can't have irrational or complex factors here. So this is going to be x in the first. I need two numbers that multiply to -8, but subtract to give me 2, and that's going to be -4 and +2. And if you look, they actually match the two denominators I have up in my numerator. So sweet. What that tells me is that my common denominator is going to be x plus 2, x minus 4. X plus 2, x minus 4. Okay? So we're going to do the same thing we did. Now this is where things start getting a little bit complicated at the beginning, but then hopefully you start seeing the connections here. So I'm going to multiply that common denominator by my numerators. So in the top part, the numerator of my big fraction, I have 4 times x plus 2, x plus 4, it's minus 4, all right, over x plus 2. You with me so far? So all I did was take my common denominator right here and multiply it by this 4. And then I kept my x plus 2 in the denominator. Plus, now I'm going to do the same thing for the next part of my fraction, which is going to be 2 times my common denominator. I'm just going to pull it over a little bit. 2 times x plus 2, x plus 4, all over that common denominator, which is x minus 4. So that's all in the numerator, because here now is my big fraction bar. And now we're going to move on to that denominator. So again, I'm going to multiply through. So I can think about this as one term though. So I have my term that I have, which is 12x minus 24, times my x plus 2, x minus 4, all over my common denominator, which is x minus 4 and x plus 2. So again, I'm going to remind you, let's try one more time, that this 4 right here is the same as this 4, and this 2 is the same as this 2, and here is my x plus 2, which is right here, and here is my x minus 4, which is right here. And then this part right here is just my common denominator. This part here is my common denominator, this part here. So I'm multiplying through by that. And this 12x minus 24 is this 12x minus 24. And then nothing else changed in the denominators of the minor fractions. So now it's cancel time. This is my favorite part. So the x plus 2's cancel, and I do one at a time. Don't cancel through the whole thing. It makes things very confusing. So here's my big fraction bar. So what's up in the top left here? These, like I said, these two canceled. So I'm left with the 4 times x minus 4 on the left side. On here, the x, I'm sorry, this is supposed to be an x minus 4 here. So they cancel. And I'm left with plus 2 times x plus 2. And then I'm left with, down here, these both cancel. And I'm simply left with 12x minus 24. Now what are we going to do? All right, let's do some multiplying out now because I know I can simplify this a little bit more. So let's take this and distribute this. It seems like we're going in circles here, but 4x minus 16 plus 2x plus 4 all over 12x minus 24. Let's combine like terms. 4x plus 2x is 6x. Negative 16 plus 4 is negative 12, all over 12x minus 24. And I'm seeing some red flags here because I can factor out a 6 with an x minus 2 left over in the numerator. In the bottom, I can factor out a 12 with an x minus 2 in the denominator. These two cancel. This cancels once and twice. And my final answer is 1/2. Love when that happens. All right. So write down what you need to. I don't want to jump up to B yet until I know that you're feeling good about this. And why don't you try and do B? If you felt that was okay, why don't you try B? Try to find that least common denominator. All right. Then multiply the top and bottom by that, and then distribute it to all terms. See if you can do that part, and then maybe start it and make sure your first few steps are okay before you continue it. And I know this is a little bit of a long video, but it has to be, unfortunately, because I have to do this nice and slowly or people get confused. So here we are in B, and you look at this and you say, wow, what a hot mess this is. But again, the first thing we're going to do is we're going to rewrite it. All right, so let's rewrite it. Here's our big fraction bar. We have x over x plus 6 minus 1 over x plus 2. And again, I like to put these in parentheses to remind myself they are protected. All right, now in my denominator, I have x squared minus 4 over, and now I'm going to factor this. And we have x squared plus 8x plus 12, so I have x in my first position. I know they're both positive because I'm looking for two numbers that multiply to 12 but add to give me 8, which is 6 and 2. And again, very nice. I have the same denominators up in the numerator. So what that tells me is I'm going to multiply the top and the bottom, the numerator and the denominator, by x plus 6, x plus 2. Oh, I hate to put it here. 8 plus 6, x plus 2. Remember, this is through the numerator. So let's see if we can do this slowly and say, again, I'm going to distribute this. So it's going to be this times this x. So here's the x in my original numerator. Here's the x plus 6 in my denominator, right? Here's my big fraction right here. All right, and then we're going to multiply by that x plus 6, x plus 2. All right, minus, and once again, here is the 1 over the x plus 2 from our original fraction, and then we're simply going to multiply this by x plus 6, x plus 2, and we're going to do the same thing in the denominator. Here's our original x squared minus 4, all right, over x plus 6, x plus 2, and we're going to multiply the numerator by that common denominator, x plus 6, x plus 2. Now it's cancel time. Alrighty, so Love this part. I think I've mentioned that. So in this case, these cancel. So what am I left with? I'm left with x times x plus 2 in my numerator minus, these cancel out, and I can kind of, don't worry about that 1, but I have an x plus 6 left, all over, in this case, cancel with these two, and I'm left with my x squared minus 4. And now we're at the same point where we were right over here with this one. So we're going to multiply this out, distribute the x, and you get x squared plus 2x minus x minus 6, watch that negative sign, all over x squared minus 4. So now what do we get? X squared plus x minus 6 over x squared minus 4. And I'm hoping you can see that both of these are factorable. My numerator is simply going to be x. So I need the numbers multiply to 6, but subtract to give me 1. Remember, there's a 1 hiding here. So it's going to be a positive 3 and a negative 2. Whoops, got the x here. And then my denominator is the difference of two perfect squares. Beautiful, because these cancel out. And my final answer is x plus 3 over x plus 2. And again, you can protect them with those parentheses because you have to remember that you are not allowed to do anything like this and get 3 over 2 being the answer. All right? That is simply not allowed. So basically what you can consider doing is protect them if you want to. No points will be taken off for that because you cannot cancel out those x's. So like I said, this is probably the longest video I've done, so my apologies for that, but this is kind of a difficult subject. Lots of places to make errors. You saw a couple of times I put a plus sign where I wasn't supposed to, or a minus sign, but I caught it, and if I didn't catch it, then it could really mess things up at the end. So if you get to the end and there's nothing to cancel out, then go back and do it again. And I know that does not sound very pleasant, but unfortunately, it's the only way to make sure that you're doing these properly. All right, so we'll spend some more time in class doing them. Hopefully you will be able to master this in just a couple of problems, and then we're going to move on to long division, which is super cool. All right, so until then, make good choices. Bye.